Hi Algebra 2, this is Unit 10, Lesson 6, and today we're going to simplify rational expressions. So basically to simplify, we really want to find common factors, and then we'll just divide out those common factors. So if you're looking in exercise 1A, these are a little bit easier. So I'm just going to look at the numbers, like 3 goes into 6 2 times. And then with the letters, there's 5 x's on top and there are 8 x's on the bottom, so I'm going to eliminate the 5 on top with 5 of the 8 on the bottom, but I'm still left with x to the third. And the reverse is true for the y's. I got 3 y's on the bottom, and I'm going to cross those out, and I'm going to cancel out 3 of the y's on top, but there were 6, so I'm still left with 3. So on the top, I have y to the third, and on the bottom, I have 2x cubed, 2x to the third. All right? So B, 4 goes into 25 times, and I have the 2 x's on the bottom are going to cancel with 2 of those x's on top, but I'll still be left with 8, and nothing happened with the y's at all. So I actually don't have anything in the denominator, and in the numerator I have 5x to the 8th, y to the 8th. And for C, 7 goes into 21 3 times. The 3 x's on top are going to cancel with 3 of the x's on the bottom, but I had 5, so I still have 2 left. And the 1 y on top cancels with 1 of the 8 y's, but I still have 7. Now I do need a placeholder of 1 on top, and then I have 3x squared y to the 7th. So those are just monomials, so those were pretty easy to do. You're just going to be canceling out. Here's a multiple choice monomial. All right, so 10 and 15 are both divisible by 5, so it gives me 2 on top, and that gives me 3 on the bottom. The 2 x's on the bottom cancel with 2 of the x's on top, but I'm left with x to the 4th. And the 3 y's on top cancel with 3 of the y's on the bottom, but I'm still left with 3 to the y. So I have 2x to the 4th, 3y to the 3rd, and that's choice 3. All right, but you do have to put in a stipulation about what would make the expression undefined. So in that one, we would have to say, y cannot be equal to 0, of course. So speaking of when is it undefined, that's what exercise 3 is all about. State any excluded values for the following rational expressions. So remember, the denominator cannot equal 0. So we just take the denominator, set it equal to 0, and solve. So basically, x cannot equal 3. All right, sometimes I might have to factor to do that. This came out a little blurry. So that says x squared plus 6x on the bottom. So I want to factor that. So I set it equal to 0. This one I'm going to do a GCF, and I'm left with x plus 6. So basically, x cannot equal 0, and x cannot equal negative 6. And this last one right here is a trinomial. This is x squared minus 7x plus 12. All right, that's a plus right there. So my factors are x minus 4 and x minus 3. So basically, x cannot equal 4 and x cannot equal 3. All right, so here's a rule just on simplifying rational expressions. When simplifying rational expressions that are more complex, and we're going to do that on the next page, we always factor first, then identify any common factors and eliminate them. So the factoring can be by GCF, difference of two perfect squares, trinomials, or our favorite grouping. All right, so all these came out a little blurry. I'm not sure why. So let me just rewrite it. It says x squared plus 4x and x squared minus 16. I hope yours is not as blurry as mine is. So on the top, I'm going to do a GCF of x, and I'm left with x plus 4. And on the bottom, it's the difference of two perfect squares, x minus 4, x plus 4. And then once it's in factored form, you're just going to cancel out any common factors. So the x plus 4s were in common. So I got x on top and x minus 4 on the bottom. You cannot cancel out those x's, okay, because that's a binomial, and that's x minus 4 on the bottom. All right, B, again, I'll rewrite this because it's a little blurry here. So on the top, I hope you guys recognize that's the difference of two perfect squares, so 2x minus 1 and 2x plus 1. And on the bottom, I'm going to factor out a GCF of 5, and I'm left with 2x minus 1. and then I'll cancel out those 2x minus 1's, and I'm left with 2x plus 1 on top and 5 on the bottom. Okay, so that's all that's going on here in 4. So x squared plus 5x minus 14 is what the top said, and x squared minus 4 is what the bottom said. So the top is a trinomial. Factors of 14 that add up to 5 are 7 and 2, but it has to be a negative 2. And the bottom, x squared minus 4, is the difference of two perfect squares. All right, so those x minus 2's will cancel out, and I'm left with x plus 7 and x plus 2. So we're factoring and canceling any common factors. That's all we're doing when I'm simplifying these. So the top is 5x squared plus 6x minus 8. And the bottom is 10x squared minus 3x minus 4. All right, so these you got to do by grouping. 5 times 8 is 40. And I'm looking for factors of 40 that will give me a 6 in the middle. So that would be a positive 10x and a negative 4x. All right, so again, I'm just changing this 6x right here, and I'm making it positive 10x and negative 4x. And on the bottom, 10 times 4 is 40. So again, factors of 40 that give me a negative 3x in the middle. So let me just think what that would be. 8 and 5 is 40. And to get a negative 3x in the middle, that would be a negative 8x and a positive 5x. Okay, so I now made these each 4 terms so that I can group them. So on the top, I'm going to group together the 5x squared plus 10x. I'm going to do the GCF, so let me just show you. I'm going to group these two together and these two together. And then I'm going to group these two together and these two together to do my GCF. So on the top, my GCF is 5x, and I'm left with x plus 2. And then for negative 4x minus 8, I'm going to factor out a negative 4, and I'm left with x plus 2. In the bottom, the GCF of 10x squared minus 8x is 2x, and I'm left with 5x minus 4. And then I'm just going to factor out a 1 because I already have 5x minus 4. All right, so put these GCFs together. 5x minus 4 is on the top, and x plus 2. And then on the bottom, 2x plus 1 is on top, and 5x minus 4. Ooh, that was a lot of work. So what was in common? The 5x minus 4's, and I'm left with x plus 2 and 2x plus 1. All right. So the last thing I want to talk about is special kind of factoring happens when I'm left with x minus 1 and y minus x. So you can see they're really super similar, but the signs are off. So let's look at just exercise 5 so we can see what's happening. 9 minus 6 is 3. 6 minus 9 is negative 3. They do cancel, but you're left with a negative 1. So that's what's going to happen. 15 minus 3 is 12. 3 minus 15 is negative 12. And again, I'm left with a negative 1. So if the numbers are the same, but the signs are different, then you're left with a negative 1. So the same thing happens with this a minus b. Just to show you, if I factor out a negative 1, I'm left with negative a plus b. And on the bottom, I have b minus a. Well, that is negative a plus b. Okay, b minus a and negative a plus b is the same thing, so then they can cancel. Let me rewrite the top. That's really just b minus a. Negative a plus b is b minus a. So see how they're exactly the same? So they do cancel, but you're left with a negative 1. So that's what we're going to try on this next one. So in exercise 6, I'm going to factor out a 2, and I'm left with x minus 5. And then 25 minus x squared is the difference of two perfect squares. Okay. Now, the x minus 5 and the x minus 5, these are the ones that I'm looking at right here. These are the same except the signs are off. So yes, I can cancel them, but I'm left with a negative 1, just like what happened up top. all right? And so that's going to give me a 2 over -1, 5 plus x, okay? But that's not written there. It doesn't matter if the negative's with the numerator or the denominator. So if you look at choice 1, that's basically the answer. Okay, again, the negative can be with the numerator and the denominator. So what I highlighted in green, those were the same. They were just opposites, just like we did in exercise 5. Yes, they can cancel, but when you cancel, you're left with a -1. All right, same thing's going to happen on exercise 7, our last problem. So the top is a trinomial. I'm going to factor it, x. So the factors of 9 are 3 and 3, and I want that to be a -6 in the middle, so it's going to be -3 and -3. And then in the denominator, I'm going to factor out a -6, and I'm left with -3 plus x. So again, these are the same. It's just, they're just written backwards, okay? So actually this one, these are exactly the same. This is the same thing as x minus 3. It's the same thing. All right, so these just totally cancel, and I'm left with x minus 3 over -6. And the only problem is that I don't see that answer there. But if you were to factor out a -1, okay, it would be choice 4. Choice 4 is equivalent to that. If I factor out a -1, I'm left with -x plus 3, and on the bottom I would be left with 6. All right, so see, there it is. So sometimes you might have to play around with those answer choices as well if they're not exactly the same with our signs. All right, and that's it for today.